Welcome to Emerging Technology Horizons. I'm Mark Lewis, the Executive Director of NDIA's Emerging Technologies Institute. And with me in this episode is Dr. Robie Samanta Roy, well known to so many of us in aerospace and defense, one of our thought leaders in the whole area of emerging technologies. Robie has had a career that has included government and industry. You were at OSTP, you were a staffer on the Hill, you were very senior at Lockheed Martin, and now you're the Chief Operating Officer of a very exciting new enterprise, Elantra.aero, that I hope we'll get to talk about in this episode. Robie, I know also you've done significant fundamental research, you've done plasma simulations, you have let's see, bachelor's, master's, PhD from MIT. We shared thesis advisors, Dan Hastings at MIT. You also have a master's degree from the George Washington Space Policy Institute. So welcome. Thank you for joining us.
Mark, thank you so much for having me. You really studied my resume. Don't embarrass me with all that.
I should tell you when the staff was saying, "Oh, here's the resume," I said, "No, I think I know that one. I think I know that one by heart." And I'm glad to say we've been friends for what, more than 3 decades now, and have followed each other, I think, and have had a chance to interact quite a bit over the years. So again, thank you so much for being on this episode. Mm-hmm. So what I thought we'd focus on a little bit is talk about some of the challenges facing us in trying to introduce emerging technologies. Why do we have these challenges? What are the obstacles that we have to get past? And I know this is something that you've thought about extensively in your government role and your industry roles. What makes it so difficult?
Well, thank you, first of all, Mark, for coming on the show. And yes, we are in the same academic family, going back to Dan Hastings. And it's kind of interesting that, with my background in academia and in government, both sides of Pennsylvania Avenue, and now in industry, both from a large corporation, had 7.5 wonderful years at Lockheed Martin, working in the CTO's office and then in government affairs, and now going to the other end of the spectrum, working for a startup company that is just brand new from last year, focusing on the advanced air mobility market and looking at sustainable, the decarbonization of aviation. So one of the challenges that I've seen from many different perspectives, from a technology perspective, is essentially there's always the tech push community. These are the scientists, the engineers that have great ideas that basically push a technology. And we'll talk a little bit later about the differences between inventing something and innovating on something, because that's very important. But then you have the user community that is going to ultimately use that technology. And as you well know from exposure to DARPA and the central role that the Heilmeyer Catechism plays, both the DARPA, ARPA, and other R&D organizations, that first step of trying to understand the problem is really important, because one of the key impediments in technology activities are either there's an idea that's being pushed that the stakeholders don't fully understand what the problem they're trying to solve, or that user community. And then there's the user community that wants something, but sometimes they're asking for something that's limited by what they know, or they want to, in their request, they're asking for the solution indirectly. And what is so important is for those two communities to work together very closely. And what always will, in many successful cases, is you'll have a champion, either one champion who has a foot firmly placed, that he or she will be firmly placed in both communities, or you have a champion on the user pull side, you have a champion on the technology push side, and they're going to closely work together. Yeah. And I think that really is important. When you look across from a historical perspective, many interesting cases where technologies have been fielded is because there's a technology that was solving a well-defined problem. You had users that understood and worked with the development community to basically ensure that it's not just a technology issue, but you work through policy issues, regulatory issues, cultural issues, workforce issues, right? And you had the developers, you had the operators, you had the testers, you had all those others, the folks that provided the funding, They all were a community understood the problem they're trying to solve. And what happens in many cases is you have open-ended technology development without the user community, basically providing that pull, or you have all this activity basically just trying to push a technology that may be it may not be relevant or useful in the long term.
So the Heilmeier, just for those of our listeners who aren't as familiar with the Heilmeier, series of questions that were developed by the DARPA director Heilmeier, who that kind of get to what's new about a technology, how is it different than what's been done, who cares, what are the milestones, a list of questions that DARPA program managers are usually asked to address before their programs get approved.
That is correct. That is correct. That catechism is a very disciplined way of how to basically structure a program that you want to get successfully funded. It goes back to Gerald Heilmeier. Yeah. Question number one is, what's the problem you're trying to solve? And sometimes that takes the most time and effort to frame the question, the problem, and then to propose something that that has not been done before.
One of the things that I also like about the Heilmeier is it opens up the possibility that something has been tried in the past, but conditions have changed, technologies have improved, something has been modified so that it's worth trying again.
That's right.
Could be a different user community, for example.
That's right. And a great example here is the new company that I'm with, Elantra.aero, that was started by John Langford, the legendary,
from Aurora Flight Sciences.
From Aurora Flight Sciences, the legendary aviation entrepreneur. So what we're doing, which is all out there, is we're looking at a hybrid electric, ultra short takeoff and landing aircraft that will provide an offering within this advanced air mobility market. The fundamental technology of how you're going to go do ultra-short takeoff and landing comes about by basically a blown lift wing.
Okay.
This concept has been around since the late 60s and early 70s when the Air Force, AFRL, NASA worked together.
Right.
But at that time, and we can get into the details some other time, but the details of how that was implemented would not be as effective or even affordable from a long-term operating perspective. And so, but now advances that have been made in electric propulsion, in the fact that you now have electric motors that can be finely controlled. Now, when you couple that capability with the blown wing, now you have a concept where we think it's going to be highly successful, where you can have a distributed electric propulsion system as basically providing the blown lift over a wing.
Yes.
And so this is an interesting case where the idea was a bit early before its time, although the C-17, as you know, from an Air Force perspective, did take advantage and you leveraged a lot of that. But from a really ultra-short takeoff and landing perspective, we now, with the advances in electrical motors, in basically in digital, flight controls of how you can provide pilot stability and augmentation, et cetera, this is now an example of where a technology is at a point now we can actually try to essentially leverage it and take advantage of it for real applications.
Right, and I'm assuming that you can also leverage developments in hybrid powertrains coming out of the automotive industry, for example.
Absolutely, absolutely. How you couple a turbine with batteries.
Right.
And one of the big premises, in areas like this is like, how does technology, across many different sectors, how it works together. So things that are happening in the automotive side, some things have been leveraged even on the personal electronics device side, right?
Right.
And how does that now actually migrate into essentially an aviation sector? But one of the reasons why we would do something, for instance, as hybrid electric is because we feel that the state of the art of batteries in terms of their power energy density are not at that point yet where you can really have truly effective long range, essentially transportation modalities.
Right. So since you've got the hybrid system, you basically hedge your bet against battery running it. Yes.
Exactly.
That's right.
So think about the Prius and the Camry before you get to that Tesla.
Yeah, exactly. My iPhone is always running out of power, so I would, that's my perfect example of why I would never drive a pure EV vehicle, or at least wouldn't do it yet.
Exactly.
But
that's right.
But I did actually just buy a hybrid last month, so there you go. So fascinating. So what do you view as the market? Is it civilian? Is there a military application?
There's both. As with all great technologies that I feel that firmly, there's always a dual use perspective, right? So there's national security, there's economic security, if you will. And in this market, what's fascinating is the world of advanced air mobility really is essentially the confluence of two things. There's been a lot of interest on urban air mobility, right? The short hop within an urban environment. as well as the longer range regional air mobility. And to give a lot of credit to, NASA has been advocating for the technology development for this sector.
Right.
As you know, there's about a year ago, the National Academies, they did a study on advanced air mobility.
Right.
And so there is projections that this would be an extremely expanding market. Now, of course, we always have to be guarded and not to be too optimistic. I mean, look at the very light jet market, a number of years ago that didn't come to fruition.
Yeah.
But if you look at how demographics are shifting, especially the nature of work in this, the lingering implications from the global pandemic, how are people going to travel? Coupled with the sustainable green aviation push, right? This administration is very much keen on things of how we're going to address climate change, mitigate the impacts. And so those, I think, are really some important elements. But then, when you look at smaller aircraft, there's the traditional markets of executive transport, medevac. The world of logistics is getting reimagined, right? So when you look at, not only long haul, but the middle mile, and then the last mile, when people talk about, for instance, the drones that deliver that last package, but how do you get it from the big airport to a smaller distribution center? So all of these interesting dynamics that are changing on the global logistics market are very interesting. And I think, also one of the other implications on the pandemic is, the global supply chain has had some fundamental shocks. So we have to really think through that. How does just-in-time, delivery really make sense for certain critical,
For those of us who were trying to buy toilet paper at the beginning of the pandemic, we saw the problems with that.
That's right. Yes. So these are some really fundamental issues. But at the end of the day, we are taking a very long-term strategic perspective on all of this. And so as the confluence of all these factors come together, we feel that this is a very important effort going into a market. The confluence of technology is there. And it's not only just going to be within the US, this will be something that really has also international perspectives. But on the military side, I mean, the world of electric propulsion enables acoustically quiet, quieter operations. And so you can now conduct, logistics, supply, infiltration, exfiltration operations. And you can now, with the hybrid electric propulsion system, you're more fuel efficient, and you can take advantage of electrical propulsion without having to deal with any ground charging infrastructure or swapping out your batteries. So you can use your imagination for certain communities in the military that would definitely benefit.
Absolutely, stealthy, longer range.
Exactly.
Yes.
That's right.
Yeah.
That's right.
Yeah. I can imagine you must already be thinking through ways to incorporate stealth capabilities, those sorts of
So I mean, it's all about, when you talk about electric propulsion, there's the acoustical signatures are very important elements to this, right? And so that's not only important in the military sense, but also if you have a lot of these things buzzing around communities, right? You have to be worried about the environmental impact. I think the long-term important element here is worrying about the sustainability, long-term sustainability of aviation. What's the environmental impact on the globe? So it's not only going to be from an energy perspective, it's going to be about essentially that acoustical perspective, right? It's going to be about the emissions, right? And so all of that has to be taken into account, and it has to make economic sense. Right? So you're going to have to do this and think about this, not just the switches are going to be flipped, but things are going to move in that direction.
Are you thinking about a price point, for example, where typical middle-class family can afford?
Well,
or is that a little further in the future?
So I mean, thinking about the Jetsons.
Exactly. I want my Jetsons flying car.
The Jetsons flying car. So
I was promised that flying car.
Exactly. So this is something that third week on the job.
Yes.
And so these are obviously some of the things we have to work with from an economic and customer perspective. But clearly you've got to be. You cannot get entrapped in the Gartner hype curve here, Mark. Is one of the things I'm going to say, right? And so this gets back to turning around back to the whole point of technology. This gets back to an important point of, what are all those factors that are going to have to be aligned to ensure that there's a successful technology transition, right? And this is not just a tech push thing. This is how the broader set of markets, come together, and most importantly, the regulatory aspect. So in this case here, it's going to be the FAA. And so the FAA is, has to go through a measured way. They are responsible for, the world's safest airspace system, right? The national airspace system from a safety perspective. So once you start to introduce new things, how is this done in a very measured way?
Right. Yes, understood.
Ensuring that safety is paramount at the system level, the vehicle level, the human level,
Right.
air as well as ground, right? So this integrated risk management perspective has to be taken into account.
Yeah,
And we fully appreciate the folks on in our company really appreciate this. But this gets back to your whole point about tech transition is you have to be very measured and deliberate about all these things to ensure your maximum probability of success.
Right. I like your point earlier about delivering, basically I'll paraphrase, delivering what's needed, not necessarily what the user initially thinks they want. There's a famous story that's told at DARPA, might be apocryphal. If it isn't true, it should be true.
Right.
Where the U.S. Navy, the Navy SEALs had come to DARPA and they wanted faster underwater small personal submarines. So the Navy SEALs have these underwater propulsion units, and they weren't fast enough. And they came to DARPA and said, "We need this to go faster."
Right.
And the DARPA folks were having a lot of trouble. And finally, they said, "Well, why do you need this to go faster?" And they said, "Well, our SEALs are sometimes operating in really cold water, and they have to get out of that cold water as quickly as possible."
Right.
And the DARPA program manager said, "Well, why don't we just make you a better wetsuit? That's probably easier."
Yeah, exactly.
So you're right about sometimes the problem is framed with an assumed answer, and the best answer might be completely out of the box, if you will.
Exactly, which is, again, back, what's the problem you're trying to solve? So I think this is really important for your members. And by the way, Elantra.aero just became a corporate member.
Welcome to NDIA.
Thank you, appreciate it. So, I think that's one of the interesting, sort of challenges in today's world, where we are in essentially a technological competition with a near peer, a peer competition, where technology plays a very, very important role, and across all domains, right? Everything from space all the way down through the ubiquitous cyber arena. Right. And the question becomes as we develop these new technologies, now with your last job at the department, right, you had this whole litany of almost a dozen different technologies that you're trying to push.
Right.
But the question becomes that how does the user community, in this case the services, how are they articulating the requirements? Yeah. What is it that they really need? Right, and so I always talk about there's requirements with the big R, there's requirements with the little r that really gets more to what you need. And we all know that there's never been a major transformative leap in military capability that ever came from a requirement with a big R.
Absolutely.
I mean, maybe there is somewhere behind a green wall, but the question becomes there has to be this kind of give and take of understanding what the problem. And I think one of the challenges we have now, like you look at Joint All-Domain Command and Control,
JADC2.
Joint Warfighting, that's right, JADC2, the Joint Warfighting Concept. All of these things that are actually now being pushed with the individual services, with the Army's Project Convergence, with the Navy's Project Overmatch, with the Air Force is doing with Advanced Battle Management System, right? They're all approaching things from how are we going to live in this ubiquitous connected world. So the question becomes how are you articulating requirements for this?
Right.
This, I think, gets to the heart of the challenge that we have right now is how are you going to be able to encourage experimentation, but still with all the right folks, that you just don't have some sort of specially rigged event where there's no leave behind capability, but that you demonstrate something, or you're showing through a set of experiments. You have a hypothesis, you demonstrate something that leads you to the next step, and that there is that catcher's mitt, so to speak, on the acquisition, the service side, the operator side, that says we need this. And how are you going to change that into a program of record, existing, or create something new that will actually really be able to increase that probability of transitioning? And so I think that's what the department is really facing, right now. And whether it is, this broader element of JADC2, or even the journey of how you take a new airplane and put it through. So, so for instance, things like, Dr. Mike Leahy at DARPA has now, has announced he wants to do something in kind of this, how do you actually help transition some of these programs this way? And so I think all the services, OSD have all these various activities, and part of the challenge is that, how do you kind of stitch together this landscape? And from your previous position, you're pushing things on AI, you're pushing things on directed energy, on hypersonics.
Right.
How do they all flow through the system to kind of a catcher's mitt that is able to then take it, if you will, to an operational capability?
So we spent a lot of time in the building talking about the valley of death, that valley that makes it difficult to get something out of the lab into the hands of the warfighter. And one of my colleagues in the Pentagon used to say, it's actually not a valley of death, it's a mountain of death, because there actually is a lot of money that gets spent on prototyping and on demonstrations, but that never finds a final customer or a final user. The catcher's mitt, I think, is as you put it.
That's right.
So, hey, if I can switch gears a little bit,
Sure.
Although related, you've done a lot of thinking about the difference between invention and innovation.
Right.
Could you tell me your thoughts on those two?
Right. So this is actually fascinating in the national security and national defense, perspective. So invention is really the process of coming up with a new idea. You're creating something new, right?
Yeah.
You're going to end up getting a Nobel Prize because you discovered something new. Innovation is a very disciplined process to take that idea and turn that into something of value. That value in a commercial setting could be it's a product that you basically commercialize, you sell. On the military side, it actually turns into a relevant military capability, an operational capability. But it is turned into something of value. And that innovation process, while there is an element of leveraging a lot of creativity, it has to be a very disciplined process of how do you sort of ideate, how you investigate, and you implement, if you will, these ideas. And I think part of the challenge is in large organizations where things are so structured, how are you able to create that space for individuals to not just only think about innovation on a purely technology side, but in many cases, it's going to be about process, business models, ConOps, new ways of how we employ and use the workforce or personnel in the system, right? Yeah. And that, I think, is really important. So there's a big distinction. And by the way, the Defense Department, many people say they're always the first to invent something and the last to actually adopt.
Right.
And electric propulsion or a blown wing may be an interesting example of how ultimately that true ultimate employment is something that may be driven by a commercial sector with the military still helping. But these ideas went back to original government research, right? Right. And so I think what is the challenge now that the government has with things like artificial intelligence, a lot of the fundamental mathematical algorithms, the underpinnings for many of the things within artificial intelligence that DARPA, AFOSR, ONR, ARL all helped. Worked closely with the fantastic academic community in the US, right? It wasn't until you had these large-scale computing, you had access to large data, and you had this financial incentive from large tech companies that basically we saw this explosion, if you will, in what DARPA would call second wave or machine learning driven AI. Yeah. And now you come back full circle back to the department. It's like, how are we going to leverage this? We have to establish a joint AI center. We have to go do this and this. Yeah. So now the question becomes it's the innovation of adopting that for all the various purposes that you need in the department. And that's part of the challenge is it's about the culture. Data. Who's going to collect the data? Where are you going to archive the data? Who's going to be in charge of archiving and the integrity of the data?
What are your standards?
What are your standards, right? And so all of these are when you have so many, if you will, cooks in the kitchen, then things become very difficult. I see one of the things that the departments have to do is work very closely with industry to align a lot of these standards. What are the lessons learned in big data that we can apply? Of course, there's other extra elements of security that have to be provided, right? Right. But I think this is going to be really, really important in some of these areas for a very close government-industry relationship to leverage that innovation that has taken place out in the commercial sector and bring that to all the specific applications that the department needs.
So the irony, by the way, of the U.S. government planting the seeds for artificial intelligence and then trying to play catch up and leverage commercial, that was not lost on us when I was on the E-Ring.
Oh,
we
absolutely.
talked about that quite often.
Absolutely. And the National Security Commission on AI, they did a great job. I think what is it, 728 pages of their final report. Yeah. But it pointed out not only the software and all this other sort of supporting technology, but even on the hardware side. Right. The fact that you need specialized hardware now, and the whole aspect of what's happening with essentially integrated circuits and home advanced microelectronics sector, These are all things that are really related.
Right. Again, when I was in the building, we spent a lot of time on microelectronics, and that was a similar situation where the Department of Defense is now several generations behind the commercial curve. This is an area that the Department of Defense helped some of the fundamental work that led to this.
Absolutely.
And now is having trouble getting on the commercial curve.
That's right.
So we at the Emerging Technologies Institute, we've got our work cut out for us in getting that message across.
Absolutely.
Hey, so as we wrap up, I want to pick your brain a little bit about workforce issues. Right? You spent a lot of time in your career, and especially at previous position at Lockheed Martin, but interacting with academia, mentoring the best and the brightest in the aerospace and defense sector. Where are we in terms of our technical workforce, and what do we need to be doing to ensure that we've got the best and the brightest minds available to work on the problems of interest for national defense?
Yeah. So, Mark, this is a huge topic, and that's like a whole separate discussion of itself. So
we can do that. We'll bring you back.
So there are a number of sort of salient points to point out here.
Yeah.
Number one, it is critical. There's been not another time in our history, I think, where the government, the national security sector, really needs top scientific and technical talent.
Right.
Yes, there was this whole push during the space race. Apollo set off an entire generation. Many of our mentors, basically, they got into aerospace or just technology through that big push. But now with how things have so globalized, and the speed at which technology is getting innovated on, it's very important. And the question then becomes is how do you recruit and you retain talent?
Right.
There's a couple of things. So first of all is you're going to have to come to grips with, we are not going to keep people in one job in one sector their entire careers.
Right.
That ship has sailed. So the question becomes is how does government and industry and even academia all work together as with a one national purpose of how we basically take talent and enable them to flow across these different sectors. This is not a new idea. There's a lot of folks in OSTP in the past that have kind of thought through this, that how are you able to let individuals gain experience? They're trained in academia, they may do some research, they go into government, they come into industry, and how do they flow back and forth? There are a lot of impediments in able to do that. Conflicts of interest, people talk about, but we have to worry about confluence of interest.
Right. I love that term, confluence
of interest, right? And so I think that is really important to take a look at regulatory policy impediments that don't allow individuals to do that. We have to obviously have egregious conflicts of interest in mind, but we have to realize the broader issue is a confluence of interest. I think that's important. And then the other issue is we've got to recognize that our government needs that technical talent to also go into senior leadership positions.
Right.
We've got to have, and it may not be the super researcher, but at least you're technically literate to be able to make these decisions and not, years down the road realize, oh, my requirements actually, it just violated some law of physics.
Yeah.
Right?
Yeah.
Right. And so
right.
I think that is really important. So the flow and the ability to actually give incentives for technical people to basically take senior leadership positions. But individuals that are not just great technically, they're going to have to be able to be very cognizant of that user community and be able to almost have, I always sometimes joke, you need a social studies degree too, to be able to deal with all the diplomacy and things like that, because that is so important in today's world.
Yes, I think we both know examples of absolutely brilliant people that you would never put in the Pentagon. No good could come of that.
Yeah,
but agree with you completely. We really do need the best and the brightest making these decisions because of how important they are.
Exactly. And lastly, like how DARPA does great. What is great about DARPA is you come in with your expiration badge. Understand that people are going to come and go through the system, and contribute, gain experiences elsewhere, and flow through the system. And their ultimate goal is to advance the national and economic security of the nation.
Robie, I'm going to let that be the last word. I've really enjoyed this conversation. I hope you'll come back because we've just scratched the surface of some of these issues.
Wonderful. Thank you so much, Mark, for the opportunity, and good luck with the ETI. It's a wonderful opportunity. Thank you.